Hi guys, this is part 2 for the chapter Force and Pressure in Motion. So all the theoretical stuff we have already covered in the part 1. So in part 2 what we're going to do is we're going to look at pendulum and we're going to look at other mathematical stuff of the chapter. Okay? So like the first thing is a pendulum is a small bob which is attached to a fixed point through or with a string. Okay, so that is your pendulum. Now, so what pendulum does is we pull the pendulum up till here, let's say. Okay, so let it go, and it comes down, comes to the mean point, and goes further. Okay, so that is the one part. And then it again comes back to the original position. That is your one oscillation. Okay, you start from one point, go to the extreme end on the other side, and then come back. That is your one oscillation. While doing that, it goes to this path. Okay, and the point in the middle, the center point, is your mean point. That is the point where the pendulum relaxes. Okay, it's just hanging there. It's not moving. It's not going anywhere. It's just there. That is the mean point where there is no motion. So the highest point, okay, or the furthest point that you pull, and this is the furthest point that we have pulled this bob. Okay, and the furthest point that it goes up to on the other side, that is the amplitude. Okay, amplitude is measured from the mean point till, let's say, that point. This is your amplitude. And on the other side, from this point, the mean point, till this point, okay, the furthest point that it goes up to is your amplitude. Now let's say you put the frequency to the highest point and let it go, and you're just checking your time watch, okay, or like your stopwatch, checking the time. So in 1 minute, how many oscillations is it going to make? Okay, that, or let's say it starts from this point and goes to that point and comes back, and it takes 2 seconds to complete that. 1 second for it to go from here to there, and 1 second for it to go from here till here. So it is 2 seconds for it to complete one oscillation. So if it is 2 seconds for one oscillation, how many oscillations are going to be there in 1 minute? Okay, that is your frequency. Number of oscillations made at a particular given time duration or time period is the frequency. Okay, in this case, in 1 minute it is going to be 30 oscillations. How? 1 minute is 60 seconds, right? So you divide it by 2 seconds. Second and second gets cancelled. So 30. So the frequency will be 30. So that will be your frequency. So we have talked about how the length is the most important thing. If there is a change in length, the time period, that is the time taken for it to start from one point, to go to the other point and come back to the point where it started, okay, to do that complete oscillation, time period changes. Okay. That's all that you need to know for pendulum. Now let's move on to distance and displacement. Okay. Let's say there's a boy at point A and he moves on to point B. Okay, and let's say this distance is 4 centimeter and this So the distance the boy traveled is going to be 4 centimeter plus 3 centimeter, which is going to be 7 centimeter. What he did was he walked down this path, went to that point C, and then he went to B. So he covered this whole length. That is the distance. Okay. Now displacement means the shortest point or shortest distance from this point till this point. Okay, from the starting point till the end point. So okay, so let's say started from point A to point B, and that is the distance. Displacement would be the shortest distance. This straight line from point A to point B is the displacement. Now, how do we calculate displacement? We just calculate displacement by using Pythagoras theorem. This is the hypotenuse. So, hypotenuse is equal to root over 4 square plus 3 square. This is going to be 16. This is going to be 9. So, 16 plus 9 is going to give you 25. Okay, and root 25 is 5. So it is 5 centimeter. So in this case, displacement is equal to 5 centimeters. So you can understand from this equation and this whole calculation that displacement is always going to be less than the distance. Displacement is never going to be more than the distance. It's always going to be less. It can be equal. Okay. In this scenario, like for example, let's say there's a circular path. Okay. So the guy starts at this point, point A. Okay. Starts at this point, point A. Goes around, okay, and comes back to the same point. In this scenario, displacement is zero. Why? Because the shortest distance from where he started to where he ended is 0. He is right where he started. So he has not covered anything according to displacement. But the distance will be the overall perimeter of this circular area. Okay. Now, if a person is walking down a straight line, then the distance and the displacement is going to be the same, because the distance is the shortest, okay, possible straight line from point A to point B. In this scenario, distance and displacement is going to be same. In the previous scenario, a circular scenario is basically, it can be other things too. Okay, a scenario where a person starts and ends at the same place. Like for example, it can also be a square scenario. You know, he starts at point A, goes to point B, goes to point C, goes to point D, and again comes back to point A. In that case, again his displacement is 0. If the body starts and ends at the same point, then displacement is 0. But in this case, if the distance covered is a straight line, then the distance and displacement is going to be equal. Okay? And these are the two scenarios which we need to focus on, and these are the only two scenarios that you need to know for now. Okay? Next is velocity and speed. Okay? Now let's say there is a car. Let's say there is a car, okay, and the car is moving this way. Speed is 40 km per hour. Okay. Now imagine if there is another car in the background. Let's say there is car B in the background and this car is going that way. Okay, so what's happening is there is crossing path. Okay, they're crossing. And the speed of this car is again 40 km per hour. Okay, so if we take one as the positive and the other as a negative, then what we are describing is basically velocity. Okay, so this car is going that way, so that is positive. This car is going negative. So this car is going this way, so this is positive, and this car is going this way, that is the left side, and that is your negative. And that is how we determine whether it is a velocity or speed. Speed doesn't have B, velocity has it. Okay, now why this? Now let's look at uniform and non-uniform motion. Okay, now imagine there's a starting point, there's this ending point, and there are three bodies. Okay, there is one A, there is B, and there is C. Okay, so they all started from this point. Sorry, it's not a straight line. So they all started from this point. Okay, at 9 a.m. they were all here. They were all at the starting point. Okay, at 9 a.m. they were all at the starting point, that is here. And let's say at 9:10 they covered, A covered this much, B covered this much, and C covered this much. Okay, so which one from these three bodies was the fastest? Is C. Why? Because it has covered the largest distance in the given time. The given time is 10 minutes, right? During that 10 minutes, it covered the largest distance compared to B and A. Compared to A, B is faster, and compared to B and A, C is faster. And in this case, C is the fastest. I think this will help you solve the questions out there in the book. There are certain questions based on this, and this will help you out. Now, as I was talking before, back to uniform motion. What does uniform motion mean? Let's see. So all these distances are equal. These are 10, this is 10, let's say meter, 10 meter, 10 meter, 10 meter. Okay? So a person starts from this point A, goes to point B, starts point A, point B, point C, point D, and point E, which is also the end. Okay? So starts from A, goes to B, C, D, and E. If the person covers each of this section same time, that is in this case again 2 seconds. Okay, covers 10 meter in 2 seconds, the next 10 meter in 2 seconds, another 10 meter in 2 seconds, and last 10 meter in 2 seconds. Then the body is said to be in uniform motion. That is, as the time changes, the distance covered is not changing. Okay? But if, let's say, it takes 4 seconds for the second one and 3 seconds for the last one, time period is changing, so the speed is decreasing, right? We discussed before in the previous scenario that at a given time, if you're covering the larger space, then it means the speed is more, okay? And what it also implies is to cover the same distance, if it's taking more time, then again speed is low. So what is happening is there are two scenarios, okay? So this is the direct and inverse proportionality of speed with time and distance, which you'll understand in later classes. In this case, again, what is happening is the distance is same. Okay, so we don't have to worry about the distance, we just worry about the time. So this one is 2, this becomes 4 seconds. Time increases. So what happens is, the body slowed down out here. Okay, in this case again it was 2 seconds. So compared to 4, it is less time. So in this case again the body became faster, and in this case again time is more, so the body slowed down. If we were to check the speed, okay, how would we check the speed? It's very simple. In this case, it's 10 divided by 2, okay, so that would be 5 meter per second. In this case, it would be 10 divided by 4, which is 2.5 meter per second. In this case, again 5 meter per second, and in this case, we have 3.33 meter per second. Right? So we can just see the speed out here was 5, and it increased to 2.5 here, and again it increased, and again it decreased. So what is happening is the speed is constantly changing. Okay? So in the first scenario where the speed was not changing, the time was not changing, and the distance covered was not changing, then it was, the body was in uniform motion. Now, since the speed is changing and the time is changing, then it means that the body is in non-uniform motion. Next, we move on to other two vector and scalar quantity, that is mass and weight. So we have already discussed that mass is the amount of matter that is present in the body, right? And we have units for mass, that is grams, kg and other stuff. And we also talked about weight is basically mass and the gravitational force, right? So how do we get it? So weight is basically mass into gravitational force, okay? And we also discussed that gravitational force is basically meter with acceleration due to gravity is basically, so weight is basically mass into acceleration due to gravity, and we have also discussed that acceleration due to gravity is a fixed value, that is 9.8 meter per second square, or to simplify you can take it as 10 meter per second square. If it is not mentioned in the question to take g as 9.8, then you can take it as 10. Okay, if it is not mentioned. If it is mentioned, then you take it as 9.8, but if it is not mentioned anywhere, then just take it as 10 meter per second square. Why? Because calculation becomes easier. So let's say the mass is 10 kg. Okay, then the weight is going to be 10 into 10. Okay, so you can just write it as Understood? That is weight. F is force due to gravitation. kg is the mass. There are a bunch of calculations, okay, questions, numericals in the book. Just go through them, try to solve them, and send it to me. If there is any problem, just ask. What I want you to do is, I want you to first try it out. Okay, I've basically told you how to do the questions. What I want you to do is try it out. Don't ask any tuition teachers, don't ask your friends, don't ask your parents, don't ask anybody. I want you to try it out. If you cannot try it out, if you cannot solve it, I'm always there. Just contact me, and if you've tried it, just send it to me, and I will help you solve it if I help you understand. And I'll make another video after all of you or most of you have, sent your numericals to me, solutions to the numericals to me. Then I will help you out and we'll discuss further. Okay, that's it. Part 2 and